vector to offset. The image is offset based on how the sheet part is set up. You can further adjust that offset in the tile property. You can set a rotation value to rotate it. We also need to know whether it's overlapping or not, because it has to be drawn later. So what it would do is it would calculate everything it needs to know about this and store only the relevant information it needs to draw, and then draw it again later. For convenience, we'll have a Boolean right in tile to determine whether or not you can stand on it. Also for convenience, if it's solid or not. Some of them you can stand on, like platforms, but they may not necessarily be solid. And we also need to know if it's spikes. So this could be spikes or lava or some kind of thing that you wouldn't want to stand on. And if the event is active, so if it's the spring platform and it's in the middle of animation, you don't want it to re-trigger that animation. As long as that animation is active, it's not going to restart the animation. So it would wait until the animation's done, in which case it would have bounced you into the air. It wouldn't restart again unless you land on it. We'll also need to be able to put monsters down on tiles, and so that would require a monster type at a monster starting location. If this is set to empty, then we know there's no monster there, and it won't write that information out to file. It only writes relevant information to file. Before we can put this in here though, we're going to need an actual monster type somewhere. So we're going to go over to the Solution Explorer, right click on Platformer, Add Folder, New folder, and we'll call it monsters. Right click on monster, and we'll call this one, this will be a class, we'll call it monster. I've started making a couple of monsters, so we're only going to have 2 monsters. Let's put this above the monster class. We'll flesh that out later. None, meaning there's nothing there. Or it could be a mouster or a hellcat. So save that. Let's just get rid of this for now. So now monster type's something that we can actually talk about. Okay, let's make a constructor for the tile that can take an index and a tile type. The index is which sheet part belongs at this location. The tile type is what type we actually want it to be. Set the default scale to vector to 1, scaling 1 in the x direction, 1 in the y direction. Monster start, we'll set to there's nothing there. Monster type none. We want to be able to clear the tile. So we'll set the index to 0, type to empty, scale back to 1. This is if you've made a bunch of changes to a tile and you want to reset it completely. Anything new for properties that you add to a tile, you'll have to make sure to add them in here as things to be reset. Stand on is false, spikes is false, solid, false. I don't usually like to do this because it can confuse people. Event active is false, and the monster start will be none. Okay, so that should completely reset that tile. Something that's interesting is we're going to have these things that are flagged as overlaps. So we'll want to put all the processed information for an overlap into a processed tile class. We'll just put that under a regular tile class. Process tile. And all it should have is a position, a scale, basically anything that it needs to actually draw, where it's drawing from, and a way to add it. So taking in the position, a source rectangle, rotation, vector 2, size, and just assign those. This equals source rect, rotation equals rotation, scale is equal to size. Oh, I just realized I have a bug at the top here. It should be a semicolon. Sometimes when I'm starting new classes, you may need to change the namespace back to just namespace platformer unless you want to use the usings. So we'll right click on map related stuff, add a class called map, and this will store the map over tiles. First thing we're going to need is the tiles. There's a width and a height to them, so however number across, however number high. Also need the start data where the player starts on the map. We'll need to know where on the map the camera is pointing. I had to resolve that one. We're going to need access to the sheet information when we're doing anything with the map. So this is actually referring to the one that's stored in game1.cs. We'll just pass it by reference. We'll also need process tiles for all the overlaps, how many overlaps there are. When we're scrolling a map, we'll always need a scroll offset that goes from 0 to 64 horizontally and 0 to 64 vertically. Then when it hits 64, it resets back to 0 and increments which tile is there. So that way it looks like it's scrolling very smoothly through the tiles. We'll need to know partly for visibility determination later on, and we're going to use it for figuring out what tile groups to draw. We'll need to know the starting tile and ending tile. So the starting and ending tile, technically it's a starting one across, starting one down, ending one across, and ending one down. So we're only going to look at a particular group of tiles on the map when we're drawing them to screen. We also need to know where in screen space those tiles start drawing, which is the top left corner. We're also going to need access to the actual tile images, so we'll have a texture 2D here. This is actually loaded in game 1 and it's just passed by reference into here. As long as it's not a value type, any object is not copied, it's basically just like a pointer. It's referring to it. For the purpose of drawing tiles that it's kind of building them around the center of the screen, I'm going to create a screen center that's sort of off-center because it'll be 30 to the left and 32 up from the actual center because each tile is 64 by 64, so I kind of want them centered around the middle of the screen like that. Also need access to sprite batch. Let's go ahead and start the constructor for making a map. So we'll pass by reference the list of sprite parts. We'll get by reference sprite batch. So now, when I say sheet is equal to SHT, this list of these sheet parts is actually this. It's just now we're accessing it from inside map. Let's say sprite batch is equal to SPR batch. Same sort of idea. Now we'll allocate our tiles. Let's set some constants for how many tiles wide and how many tiles high a map can actually be. So this would be the maximum amount you can have on a map. To do that, we'll go to the top here. Want public access to it probably. Constant integer of the tiles wide, set to 100 maybe. You might want larger maps. You can always limit your map sizes just by making your levels smaller and then just have it store what it needs to store to file. We'll have a tile span X. This is the number of tiles wide that can be visible at once on the screen. Since they're 64 by 64, I'd say we want to go roughly 14 tiles horizontally and probably 10 vertically. So that would actually be 28 tiles in total across, and this would be 20 horizontally. Some of the images might be really huge, and you don't want them to disappear as they go off screen, so you want to give them a little bit of extra room to scroll off before they disappear. Instead of saying like 9 and 6 or something, we'll say 14 and 10. So we'll say this is tiles wide, this is tiles high. And just to avoid any possible null errors, let's just make sure these tiles have something in them. You could have them be null, but it would require a lot of rigorous testing throughout your code. Go through them all and make them so that they're not null. They're assigned as empty tiles. Only the ones that are not empty are actually going to be stored to file, so don't have to worry about that. Make our overlap tiles. Process tile of 250. We'd never use up to 250, I don't think, but just to be safe. Looks like we got a bug here. Oh yeah. Got to be able to have more than one. So we'll do the same thing for the process tiles. We'll just initiate them all so you don't end up with any kind of weird errors. The overlap tiles, each one is equal to a new process tile. Let's set a starting location for when we're editing. We'll just set it at location on the map at 5,5. So you could do this too. Oak is equal to new point 5,5. We'll set the start data is new start data log.x log.y. We could have set this up so it just passes in a point, but oh well. Screen center. We might want to change which tiles are used. So we'll have a set tiles image, tiles picture, set the tiles image, tiles picture. The reason why tiles image isn't actually stored in the map class is because it may have lots of different graphical elements that may be used in other classes for other things, such as particle effects or whatever. We'll need a way to add tiles. So public add tile, taking an index of which tile you want to add. Before we add a tile at a location, though, we want it to be empty for sure. So let's also have a delete tile here. We can call delete tile from here to make sure it's empty. Delete tile. Now what delete tile does is it'll go through all the potentially occupied tile locations. First we'll get the index at the location where the editor is likely deleting a tile. So we'll get the index to find out how many tiles wide it is, how many tiles high, and we'll start at integer b is equal to location y, and when it is less than loc.y plus the sheets using the index tiles high b++, and loop through that. Same sort of thing with a. Integer a is equal to the location x. A is less than that location x plus its number of tiles wide for that sheet part. Now we want to be careful, so if b is greater than or equal to tiles high, because it might end up going off the map if the tile location is right at the bottom, for example. Say -1, just to be safe. Break. Oh, I'm missing a bracket here. Same thing with a. If a is greater than or equal to tiles wide -1, and break. And that completely discontinues the loop. For a comma b, we'll call the clear function to clear that specific tile. So now when we go to add tiles, we don't have to worry about there being potentially partly occupied or completely occupied tiles that it's partly overwriting. So we'll set the new tile at the location, set its index to the desired index, and we'll set the offset to whatever the default offset is for it based on the sheet part. Now we're going to loop through them just like we did with delete. B goes from the location to the location plus how many tiles high it is. Let's just copy this here and paste it in here because it's the exact same idea. Let's get the tile type as a type just to make this a little easier. Sheet I, the type. Sheet already stores whether it's solid or if it's spikes or whatever. So let's make sure that we set the appropriate values for this particular tile in accordance to what it says on the sheet part. First we'll copy the type for convenience. And like I said, you'd be able to modify the type possibly depending on what kind of editing you're doing to the tiles in your level. So if it's a solid, type solid, or if it were tile type spring, or if it were tile type platform, or tile type spikes, no more brackets around this. For any thing that's solid or a platform, the feet would kind of be behind it a tiny little bit. If it's overlapping, like if it's grass, solid grass, the top of the grass would go over top of your feet. All the spring platforms, your feet can kind of go behind them a bit. Same with the spikes. So if it's any of these, we're going to make it an overlap. So overlap is true, and any of those you can also stand on. So we'll say stand on is true. If it's spikes, let's say that it spikes. True. And we'll also say that it's solid. Is solid. You can't really fall through the spikes. And if it's not spikes, if it happens to be type solid, then it would be solid anyway. Is solid is true. That'll be useful for collision detection later. It's a lot more convenient than using the index to look up a sheet and then check the sheet to see if it's solid. You can just directly check the tile. It's a little bit faster that way.